Welcome back, students. So in this video I'm going to discuss the topic called waves. So the waves contains topic discussion of topics are, first of all, waves. We have to start with waves, then sound, then beats, Doppler effect, along with stationary waves. Let me in glance tell the topics: waves, sound, where beats, Doppler effect, and stationary waves. Okay, let me go to the synopsis. Okay, so first one, waves. What is a wave? It is the motion of disturbance in a medium is called wave motion. So if a disturbance is set up in a medium, it is called wave, and if the disturbance spreads in the medium, it is called as wave motion. Then what is the amplitude of the wave? If the particle is get disturbed, then it is called wave. And how much is the maximum displacement? How much is the maximum displacement of the particle from mean position? If a particle disturbed and it makes oscillation, how much is the amplitude of the maximum displacement of the oscillation is called amplitude. What is amplitude? It is the maximum displacement from mean position. Then go for what is wavelength and frequency. It is a distance between two particles in phase, or you can say what is wavelength. Wavelength means it is a distance between any two crusts or any two troughs. Distance between any two crusts or any two troughs. It is called as wavelength. And what is frequency? It is the number of oscillations completed in 1 second or number of waves formed in 1 second. So the relation between frequency and wavelength is V equal to F lambda, where V is the velocity of the wave, F is frequency, and lambda is the wavelength. And it is also written as V equal to omega by K. What is omega? It is called as angular velocity. And what is V? Wave velocity. K is propagation constant. And types of waves. What are here? Mechanical waves. The waves which require medium for their propagation are called mechanical waves. Example, sound waves. So sound waves doesn't travel in vacuum because sound wave requires a medium to propagate. So that's why sound waves are mechanical waves. And opposite word, non-mechanical waves. The waves which travel in vacuum also, they are called non-mechanical. So example is light. Okay, so then what are transverse and longitudinal waves? Transverse waves means if the particle vibrates perpendicular to the propagation. If a particle vibrates perpendicular to the propagation, it is called as transverse wave. And if a particle vibrates along the propagation, if the particle vibrates along the propagation, it is called longitudinal wave. Example, if you take at light is a transverse wave, whereas sound is what? Longitudinal wave. So now let us look at the wave equations. So different wave equations and the respective displacement of the particle are given here. So different equations are y equal to a sine omega t minus kx, where y is displacement from mean position at any instant, a is amplitude, omega is angular velocity, k is propagation constant, x is the distance of the particle from origin. What is x? Distance of the particle p from the origin. So at any distance x from the origin, the displacement of the particle at any time t is y equal to a sine omega t minus kx, and other forms are y equal to a sine of t by t minus x by lambda, y equal to a sine 2 pi into bracket t minus x by v, y equal to a sine 2 pi by lambda into vt minus x. So if you see what is y? Y is the displacement at any instant of time, t is amplitude, x is distance of the particle from origin, v is the velocity, lambda is the wavelength, capital T is the time period, omega is the angular velocity, k is the propagation constant. If the particle moves along positive x-axis, all the signs are negative. If the particle moves in negative x-axis, you have to take the signs as positive. So whatever the signs of here negative, they convert it into positive if the particle moves, or if the wave travels in negative x-axis, and if travels along positive x-axis, so you have to take as it is minus signs. Okay, so next point, the elasticity or inertia of the medium are necessary for propagation of the wave. Means if any mechanical waves travels, the motion of the particle is depend upon the elasticity and inertia of the medium. That is a key point for this. Any mechanical waves want to travel in a medium, the elasticity of the medium and the inertia of the medium, that influence the motion of the waves. So next is the speed of the transverse waves in a medium under a certain tension is given by, if a transfer wave moves in a medium under like a string. So if you take a string is moved up and down. If a string is moved up and down, the waves are produced. So in that case, the velocity of the wave formed is, it is v equal to root of t by mu. V equal to what? Root of t by mu, where t is the tension in the string, I is mass, mu is mass per unit length of the string. It is not I, it is mu. Mu is the mass per unit length. T by mu means, or m you can say mu or I. Then so T is tension in the string, because whenever tension is developed, then only the waves will form. T is the tension in the string, mu is mass per unit length of the string. Then speed of the sound waves in elastic medium is v equal to root of E by rho. What is E? Elastic constant of the medium. Rho is what? Density of the medium. So here next one, speed of the longitudinal waves in fluids is v equal to, it is in elastic medium, the speed of the sound. Now it is in speed of the longitudinal waves in fluids. It is in velocity of longitudinal waves in speed fluids is v equal to root of b by rho, where b is gamma p. B is what? Bulk modulus. Bulk modulus is also written as gamma p. Bulk modulus is gamma into p, where rho is density of the medium. So next slide, let's see here, b is what? Bulk modulus. This is gamma, not y. Gamma is what? Cp by Cv. We know that gamma is Cp by V. Cp by Cv, ratio of specific heats of gases at constant pressure and constant volume. So velocity of longitudinal waves in linear medium like rod are v equal to what? Gamma by rho. So where gamma is, sorry, it is y, not gamma, y by rho. What is y? Y is Young's modulus, rho is density of the medium. At constant pressure and constant humidity, speed of the waves in a gas is directly proportional to. So see here, velocity of a sound in a gas is directly proportional to square root of absolute temperature. Remember this point, velocity of sound in a gaseous medium is directly proportional to square root of T. So speed of gas in sound is, speed of sound in gases doesn't depend on pressure. So speed of sound depends on only temperature, humidity of the medium, and the medium wind affecting the sound. Wind, when wind blows, the speed of the sound is also affected. So after this we go for principle of superposition. We know the principle of superposition. When two or more waves meet at a point, then the resultant displacement is the vector sum of individual displacements. When two or more waves meet at a point, then the resultant displacement is, it is a vector sum of individual displacements, y1, y2, y3 plus so on. So this is called the principle of superposition. So next we go for stationary waves. What are stationary waves? When two waves having same amplitude and frequency traveling in opposite direction, when they are superposed, then the resultant waveform appears stationary. That is called stationary waves. Means if you take one wave moving along x-axis, another wave moving along negative x-axis, when the two waves having same amplitude, same frequency, same speed traveling in opposite direction, when they superpose on each other, then the resultant waveform appears stationary. The resultant waveform appears stationary. So this is called stationary waves. So in stationary waves we are having nodes, and we are having antinodes. This is what? Antinode. AN. I will write it as AN. N for nodes, AN for antinodes. So here consecutive nodes and antinodes are formed in stationary waves. Nodes are the points of zero displacement. Antinodes are the points of maximum displacement. So what is antinode? It is a point where the particle vibrates with the highest amplitude. Highest amplitude is called antinode. And node is a point where the particle is at rest, permanently at rest. So that's why the positions of the nodes are xn equal to, positions of the nodes are xn equal to n lambda by 2. Positions of the antinodes are 2n minus 1 lambda by 4. So here, so we got the equations of stationary wave as y equal to minus 2a kx cos omega t. This is the equation of a stationary wave, and this is a position. Amplitude is 2a sin kx. Amplitude is 2a sin kx. So xn n lambda by 2 is position of node position, and xn equal to 2n minus 1 lambda by 4 is position of antinodes. Okay. So next point, frequencies corresponding to different normal modes of vibration in a stretched string of length L. So if you take any string, stretched string, when a string is stretched of length L between two fixed positions, so then there are what are formed? Stationary waves are formed in that string. So what is the frequency of the stretched string? Fn equal to nv by 2l or n by 2l, and we know that v is what? Root of t by mu. What is mu? Mu, or you can write it as simply m. Mu, or also known as m. Okay. So n is number of the mode of the operation. First mode, second mode, third mode, like this. First mode is called fundamental mode. N equal to 1 means first mode, fundamental mode. N equal to 2 is second mode of vibration. N equal to 3 is third mode of vibration. N equal to 1 is fundamental mode. N equal to 2 is second mode of vibration. It is called first overtone. It is called first overtone. And N equal to 3 is called second overtone. Second overtone. And here we are observing that there are different harmonics are produced. N equal to 1 is first harmonic, N equal to 2 is second harmonic, N equal to 3 is third harmonic, N equal to 4 is fourth harmonic, and so on. N equal to 1 means fundamental mode, N equal to 2 means this second harmonic as well as first overtone. N equal to 3 is what? Third harmonic as well as second overtone. Then similarly N equal to 4 is fourth harmonic as well as third overtone. In this way the harmonics, that means the harmonics will continue in the modes of vibration in a stretched string. So after the discussion of this stretched string vibrations, let us move to if in a closed pipe, there are two types of pipes, closed pipe. One is open pipe, one is open pipe. The pipe which is open at one end and closed at other end is open pipe, and it is closed pipe. The closed pipe, and open pipe means the pipe which is open at both ends. The pipe which is open at one end, closed at other, is closed pipe. The pipe which is open at both ends is open pipe. So here I have discussed about the closed pipe. Closed pipe vibrations are wavelength is 4L by 2n minus 1. Possible frequency is Fn equal to 2n minus 1 V by 4L. So for first mode of vibration, so we are having Fn here. For first mode of vibration, F1, it is equal to n equal to 1, substitute, it will be V by 4L. V by 4L. It is a first mode of vibration. then F2 will be, see here, F2 will be, substitute n as 2 here, n as 2 as 2 into 2 4, 4 minus 1, 4 minus 1 is 3, 3v by 4l, 3v by 4l. So in this way F3 will be 5v by 4l. So if you discuss the modes, it is first mode of vibration, that is fundamental mode. This is fundamental mode. This is first overtone. Any frequency greater than the fundamental is what? Overtones. So this is first overtone, this is second overtone, this is second overtone, and F1 is fundamental mode as well as first harmonic. Yeah, second here 3, number 3 will come, so it is called third harmonic. Third harmonic. This is 5 will come here, so it is fifth harmonic. Fifth harmonic. And here this is first harmonic. F1 is first harmonic. So indicates in closed pipe the frequency ratio is F1 is to, F2 is to, F3 is equal to, F3 equal to 1 is to 3 is to 5, so on. Means F1 is 1, 1 means first harmonic fundamental mode. F2 is 3, 3 means third harmonic first overtone. F3 is what? Fifth harmonic, it is second overtone. So in this way the frequencies will continue. So this is about closed pipe. If you go to open pipe, next one is open pipe. See, look at the open pipe. What is open pipe? A pipe which is open at both ends. A pipe which is open at both ends is open pipe. So the frequency ratio here Fn equal to Nv by 2L. So frequency first one F1 will be V by 2L. Substitute N as 1. Substitute N as 2. F2 equal to 2V by 2L. Substitute F3 N equal to 3. F3 equal to 3V by 2L. So it will be 3V by 2L. So in this way F1 is what? F1 is to F2 is to F3 is equal to, ratio will be 1 is to 2 is to 3. So F1 is called fundamental mode and it is first harmonic. F2 is called the first overtone and second harmonic. F3 is second overtone. F2 is first overtone, second harmonic. F3 is second overtone, third harmonic. Means this F1 will be fundamental. F2 will be first overtone and it is second harmonic, and fundamental is what? First harmonic, always first harmonic. F3 will be second overtone and it is called third harmonic. So this discussions of open pipe, so frequency ratio and overtones and harmonics. So after this we go for beats. So what are beats? When two sound waves of slightly different frequencies, superpose on each other, the resultant sound wave will have sudden rise of intensity of sound, or there will be a sudden fall of intensity of sound. The sudden rise of intensity of sound is called waxing and the sudden fall of intensity of sound is called waning. So these waxings and wanings will be formed in what? The phenomena of beats. In beats there are sudden waxings and wanings due to the superposition of two sound waves having slightly different frequencies. So let me show the waxings and wannings here. So waxing is of highest intensity, then intensity goes on decreasing and suddenly becomes 0. This is waning. Again the intensity increases suddenly and it becomes maximum. Where again the sudden intensity becomes maximum is what? Waxing. Where the intensity falls is called waning. The rise of intensity is waxing, the fall of intensity is called waning. So the waxings and wannings are formed in what? Beats. Okay, beats means one beat means one waxing and one wanning. One waxing and one vanning will form one beat. So what is one beat? One waxing and one waning. So number of beats heard per second is called beat frequency. So number of beats heard per second is called beat frequency. Then what is one beat? One beat contains one waxing and one waning. See here, this one waxing and one waning, this will be called one beat. Again, if you go for another waxing and another waning, you will call it as one beat again. So number of beats heard per frequency is called per second is called beat frequency. The number of beats per second is called beat frequency, and beat frequency formula is F1 difference F2. If F1 is greater, F1 minus F2. If F2 is greater, F2 minus F1. Totally F1 difference F2 is what? Beat frequency. So after this we go for Doppler effect. Okay, Doppler effect is what? It is given by Doppler, that's why its name is given as Doppler effect. So Doppler effect gives whenever a source of sound, it is called S, and observer O. When the source of sound and observer are moving relative to each other, if Vs is the velocity of source, Vo is the velocity of observer, then when the source and observer are moving relative to each other, due to this relative motion between the source and observer, source means the object which emits sound, observer means the object which receives the sound. It is what? Observer. Then due to the relative motion in source and observer, the observer is going to hear not the real frequency. Observer, or you can say listener, observer or listener, he is going to receive an apparent frequency. That change in the apparent frequency due to the relative motion between source and observer is called what? Doppler effect. That apparent frequency heard by the listener formula is FL equal to, see here, now I will write, see here, I will give the simple data here. Source is moving like this, observer is moving like this, and velocity of sound is taken from, see here, how to take the velocity of sound? It is taken from source to observer. The arrow mark of V is from S to O, because sound emitted from source is going to receive to the observer, means velocity of sound is from source to observer. It is denoted by V. Vs stands for velocity of source, Vo stands for velocity of O. So I will write the apparent frequency heard by the listener, FL equal to V minus VL or V minus VO. You can say L, or this is L, okay. V minus VL divided by V minus Vs into the real frequency F. This is a formula for apparent frequency heard by the listener. VL equal to, into bracket, V minus VL divided by V minus Vs into F. Okay, so this is a apparent frequency heard by the listener. Now it is given as plus or minus. How to take the formulas or signs? Here, if Vs is along V, it is taken as positive. If VL is along V, it is also taken as positive. If Vs is opposite to V, Vs is taken as negative. If VL is opposite to V, VL is taken as negative. Andre ಏನರ್ಥ ಸಿಂಪಲ್ ಏನ್ರಿ, ಈಗ ನಾವು VS ಸೈನ್ಸ್ ಇದು ಆಕ್ಚುಲಿ VS VL ಸೈನ್ ಡಿಫೈನ್ ಮಾಡ್ಲಿಕ್ಕೆ ಈ ಫಾರ್ಮುಲಾದಾಗ VS ಅಲಾಂಗ್ V ಇದ್ರೆ ಪಾಸಿಟಿವ್ ಅಂದ್ರೆ ಸೈನ್, ಈ ಪಾಸಿಟಿವ್ ಇದ್ರೆ ಪ್ಲಸ್ ಮೈನಸ್ ಮೈನಸ್ ಆಸ್ ಇಟ್ ಇರುತ್ತೆ. If VL is also along V, ಅವಾಗೂ ಪ್ಲಸ್ ಈ ಮೈನಸ್ ಸೈನ್ ಆಸ್ ಇಟ್ ಇರುತ್ತೆ. ಯಾಕಂದ್ರೆ VL is positive into this negative sign remains negative only. But suppose VS is opposite and VL is also opposite. This is source, this is listener or observer. And how to take velocity of sound? Source to listener. In this case Vs and VL are opposite to V. Then what happens to the apparent frequency? F heard by listener, FL equal to, so now I am going to write the formula. See here, Vs is opposite to V means this Vs becomes negative, and negative of negative becomes what? Positive, means V or plus Vs. Why it is positive here? Because Vs is opposite to V, and Vl is also opposite to V means this negative negative becomes positive. So V minus of minus means plus Vl. So general formula is a negative sign, but here it becomes negative plus because they are opposite. That's why the sign changed to plus. That's why you can write plus or minus here. So this is the simple technique behind this one is Vs is along V means Vs positive. Vl along V means that is also positive. If Vs opposite to V, negative. Vl opposite to V, negative. That's why we have to compare Vs and Vl with respect to V. And now Vs ಮತ್ತು Vl ಅನ್ನ V ಜೋಡಿ ಕಂಪೇರ್ ಮಾಡಿಕೊಂಡು ಸೈನ್ ಡಿಸೈಡ್ ಮಾಡಬೇಕು. Okay, so this is about the Doppler effect, and now we go for next point. See here, read this point. If a body repeats in motion along a certain path about a fixed path at a definite interval of time, it is called periodic motion. See here, periodic motion means any body which repeats its path again and again at regular interval. It is called periodic motion. So if Earth rotates around the sun, Earth motion is called periodic motion. If a swing is taken, swing, jokali, that is also periodic motion. If a body moves to and fro or back and forth, up and down, these are called oscillatory motions. If a body moves to and fro like this, to and fro, back and forth, or up and down, these are all what? Oscillatory motions. Next, 19th point. When a body moves to and fro repeatedly about its equilibrium position under a restoring force, which is always directed to equilibrium position, whose magnitude at any instant is directly proportional to displacement of the body, it is called as simple harmonic motion. So it is very simple. Simple harmonic motion means any body which is directed towards its equilibrium position and moving to and fro because of the restoring force. It moves to and fro because of the restoring force, and it is directed towards what? Equilibrium position. Then it is called simple harmonic motion. Okay, next one. The maximum displacement of oscillator on either side of mean position is what? Amplitude. You know what is the maximum displacement from either position is what? Amplitude. The time taken to complete one oscillation is period. The number of oscillations completed in 1 second is frequency. 2 pi is the 2 pi times frequency oscillator is angular frequency. So omega equal to what? 2 pi f. 2 pi f, or omega equal to angular velocity is written as 2 pi by, in terms of period, 2 pi by t. So t equal to what? 1 by f. So these the formulas listed here. So this completes the synopsis of the waves topic. Okay, thank you. Next I will continue the question. Welcome back, students. So in this video I am going to continue the discussions of questions on the topic called waves. Okay, so let me read the first question. The question is, the equation for a harmonic progressive wave is given by y equal to a sine 15 pt plus 10 px plus p by 3, where x is in meter, t is in seconds. This wave is what? Options. Option A, traveling along positive x direction with a speed of 1.5 meter per second, traveling along negative x direction with a speed of 1.5. See here, the equation is all signs are here plus. Plus indicates the wave is traveling along negative x-axis. So the A will be wrong because it is positive x-axis. So options will be negative x-axis. So in that, see here, if you compare this equation, y equal to a sine of, see here, sine of it is in the form of omega t plus kx and kx plus theta, where theta is the initial phase, omega is angular velocity, k is propagation constant. If you compare this one, omega will be 15 p, omega will be 15p and k will be 10p. K will be 10p. K will be 10p. Sorry. Okay. Then what about the velocity? V equal to omega by k. If you check this, 15 by 15p by 10p. Sorry. It has gone. So it is coming here. So 15p by 10p. 15p by 10p means answer will be V equal to 1.5 meter per second. 1.5 meter per second means the wave is traveling along x direction with the speed of negative x direction with the speed of 1.5 meter per second. So this is the answer. So how I got? First I have compared this equation with the standard equation y equal to a sin omega t plus kx. Omega will be 15p, k will be 10p. So velocity of the wave is omega by k, 15p by 10p. So velocity will be 1.5 meter per second. So option is B. So B is the correct option. Okay. Next question. I'll move to next question. I will read the question first. If the velocity of sound wave in a medium, humid air is Vm and that in dry air is Vd, then what happens to, then Vm is greater than Vd or Vm is Vd less than Vd or Vm equal to Vd or Vm is very much greater than Vd. So the option is, see here, we know that any velocity of sound in humid air, the velocity of sound in humid air is humid air is greater than dry air, means the sound travels faster in humid air compared to dry air. That's why velocity of humid air is more than velocity of dry air. That means option A is correct. So question number 2, A is correct. Okay. So velocity of sound in humid air is more than dry air. Okay. Next question. The ratio of frequencies of two waves traveling in the same medium is 2:5. The ratio of frequencies. Then the ratio of their wavelengths will be. So what happens to the ratio of the wavelengths? So we know that, so velocity of, see here, frequency is inversely proportional to lambda. So f1 by f2, how to write f1 by f2? It will be lambda 2 by lambda 1, or you can say lambda 1 by lambda 2. It is written as f2 by f1. So f2 by f1 means 5:2, reciprocal of this ratio. 2:5 becomes 5:2. So option, which one is correct here? After option 2 or B is correct. So answer is 5:2. So next question, fourth question is what? I will read the question. The maximum velocity, the maximum frequency of sound wave at room temperature is 20,000 Hz. The frequency of the frequency of sound wave at room temperature. Then its minimum wavelength will be approximately. So minimum wavelength will be. So here we know that when frequency is maximum, velocity wavelength is minimum. So lambda minimum can be written as velocity divided by f maximum. If you calculate this, Velocity is what? 20,000. Sorry, not 20,000, 340 meter. 340 meter per second. Thereby frequency maximum is 20,000. So if you cancel zeros, so what happens? 2,000 to 17. So answer will be 17 millimeter. It is 10 raised to 3 minus comes 10 raised to minus 3, 17 millimeter. 17 millimeter. Nearest option is 20 millimeter. So approximately 20 millimeter. 17 millimeter will be nearer to 20 millimeter. 17 millimeter will be nearer to 20 millimeter. So option is D. Okay. So next we go for the next question. Let us continue the fifth question. Fifth question and little question. If the equation of the wave in a string having linear density 0.04 kg per meter cube per meter means linear density 0.04 kg per meter, it is given by y equal to 0.02 sine of 2 pi it is. See here, pi it is 2 pi into bracket small t by this capital T, it is capital T, minus x by lambda. This is lambda according to standard equation. This is T, this is lambda. Now you have to calculate tension in the string. For tension in the string, we require V equal to velocity equal to square root of T by mu. T by mu or mu or small m, both are same. Mu or m, both are same. Now T equal to, it will be V square by mu. So already we know mu, but we don't know V. So for this we calculate V first. How to calculate the velocity of the wave? Using T and lambda. So velocity of the wave is equal to omega by f lambda. It is f lambda directly. F means 1 by T into lambda. So it will be, so 1 by T means 1 by 0.04 into lambda. Lambda is how much? Lambda is already 0.5. When you calculate this, it will be 50 by 4. 50 by 4 means it will be 25 by 2. Substitute here in this tension. This is tension, not a time period. This T is time period, this T is tension. So if you square this, V square means it will be 625 by 4 into this mu is already know. Mu means 0.04 kg per meter. 0.04 per kg per meter means if you calculate this, you will get 6.25 as the answer. So fifth one, A option. Now you go for sixth one. So what is the sixth one? See here, the equation of a transverse wave is given as y equal to, the equation of transverse wave is given as y equal to a sine 2 pi, make it 2 pi not p, it is pi, t by t minus x by some lambda value. Then for what wavelength will be the maximum velocity of particle will be double the wave velocity. So we know that maximum velocity of the particle V maximum is, according to the SHM, V maximum is A omega. V maximum is A omega. Velocity of the wave is velocity of wave, not simple arc motion. It is V equal to F lambda. Compare these two and it is given as maximum velocity of the particle is V maximum equal to double the velocity of the wave, 2V. Substitute A omega equal to 2 into F lambda. A omega, A into omega is what? 2 pi F. Omega is 2 pi F. It is equal to 2 F lambda. Means F cancels. F cancels. I want lambda. 2 also get cancels. So what remains? Lambda equal to pi A. Lambda equal to what? Pi A. Pi A means, which is option? here they are given in P. So pi a, this make it as pi, this also makes it pi, this also pi, this also pi. So which is option? Pi a by 4, pi a by 2 or pi a? It is what? Pi a is the correct option, not 2 pi a. So answer is C. Okay, so I'll move to next question. Consider 2 points, 7 question 2 points lying at a distance 10 meter and 15 meter from an oscillating source. If the periodic time of oscillation is 0.05 second, periodic oscillation means periodic time, capital T, wave velocity is 300, then what will be the phase difference? So phase difference, if you want to calculate any phase difference delta, I will write the formula first. Phase difference delta equal to 2 pi by lambda into path difference. For this I want lambda. So to calculate lambda, this is capital T and this is V. So V equal to F lambda, or lambda equal to what? V by F. So it is V by F, or V into T. F 1 by F means T. Substitute V is how much? 300. So 300 into T is what? 0.05. 0.05, multiply these two, you will get the answer as 300 into 0.05 is what? 2 decimals go, it will become 15. It will become what? 15. 3 5 is 15. So then substitute here 2 pi by lambda. 2 pi by lambda. Lambda is how much? 15. 15 into, what is path difference here? So here the 2 points are how much apart? 10 meter and 15 meter. So path difference will be 15 minus 10. So it will be 2 pi by 15 into, this will be pi. So answer will be, if you cancel this, the answer will be 2 pi by 3. So answer is 2 pi by 3. Dear my dear students, take it as pi. This is pi by 6. This is pi by 3. This is 2 pi by 3, means option D is correct. Okay, so 7th question answer is D, which is 2 pi by 3. Okay, so move to next question. 8th question. 8th question. So see the 8th question. A string is divided into, see here, a string is divided into 3 parts. How much? L1, L2 and L3, means L is equal to how much? L is equal to L1 plus L2 plus L3. So if fundamental frequency of these parts are F1, F2 and F3, then what happens to the fundamental of origin frequency? It will be, since F is inversely proportional to L, for wave string F is inversely proportional to L, it means it will be 1 by F equal to 1 by F1 plus 1 by F2 plus 1 by F3. So answer is C. Since F is inversely proportional to L, so L1 will be F1 by F1, L2 will be 1 by F2, L3 will be 1 by F3, the original frequency 1 by F. Okay, option is C. Now I'll go for 9th question. 9th question is, waves produced by two tuning forks are given by y1 equal to 4 sine 500 pi t, make it pi t, y2 equal to sine 506 pi t. The number of beats heard are, so I want to calculate number of beats. Number of beats heard is what? Fb equal to F1, so I write F1 minus F2, or F2 minus F1. F2 minus F1 is what? So I will calculate F1 and F2 first, then I will go for this one. So if you take this as omega t, omega 1 t, this is omega 2 t, then what will be omega 1 and omega 2? omega 1 will be 500 pi. In this, if you calculate f1 frequency, it will be half of this one, that is 250 frequency. Then omega 2 is 506 pi. So this means f2 is half of this one, because f equal to omega by 2 pi, half of this one, it will be 253 hertz. So what happens to f2? 253. So if you take the difference of these two, 250 and 253, so answer will be 253 greater minus smaller. 250 means answer is 3 hertz. It is 3. 253 minus 3, 250 means 3 hertz. Answer is what? D. So 9th question option is D. Okay, let us read the 10th question. 10th question is, see here I will read the 10th question. Equation of a progressive wave is given by y equal to 8 sine 2 pi, make it 2 pi not p, 2 pi 0.1x minus 2t, where x and y are in centimeters, t in seconds. What will be the phase difference between two particles of this wave separated by distance 2x? Again we go for phase difference. Phase difference delta x equal to what? 2 pi by lambda into x. X is already know. What is x? The distance between the two particles is 2 centimeter. X is 2 centimeter. This is path reference. 2 pi by lambda into path reference. Now you have to calculate lambda here using this equation. So here if you reinstall this equation, rearrange this equation, y equal to, it will be minus 8 sine 2 pi, it will be 2t minus x. If you compare this as t by capital T minus x by lambda in this form, if you make this as 2t minus 0.1x, sorry, 0.1x, it will be, see here, x 0.1 into x, so x it will be what? X by 10 it will be. It will become x by 10. X by 10 means 0.1x, means lambda is how much? 10. So on comparing this we got lambda as 10. So if you take lambda as 10, so 2 pi by 10 into x is how much path difference? 2 centimeter. It is 2. So totally it will be, if you calculate this, pi is 180, substitute 4 into 180 divided by 10. After this calculation, 18 4s are 72 degree. So answer is what? 72 degree is the answer. Okay, after this calculation you get 72 degree. That's the answer, option C. Okay, next question. Next question is, I will move to next question. See here, as shown in the figure, two pulses in a two pulses in a string having center to center distance of 8 cm. The two pulses are of distance center to center 8 cm are traveling along the mutual opposite direction. This comes like this, this comes like this, opposite direction. If the speed of both pulses are 2 cm per second, then after 2 seconds the energy of these pulses are, see here, whenever these two pulses move in opposite direction, first pulse moves 2 cm per second, means after 2 seconds it comes 4 cm far apart. So it comes 4 cm, and about this second pulse also comes 4 cm, means total distance is 8 cm, means the pulse 1 will overlap on second pulse. Due to this, the potential energy of the entire system becomes 0. If potential energy is 0 due to overlapping of these two, then the energy of these pulses will be stored as only totally kinetic energy. So option B is correct, because potential energy becomes 0. Whatever the total energy is totally kinetic energy. So option B is correct. So next question, 12th question. Two waves represented by y1 equal to a sin omega t, it is omega, and y2 equal to a cos omega t. The phase of the first wave with respect to second wave is, the phase of the first wave with respect to second wave is, now I am going to write first wave, y1 equal to a sin omega t. Second equation, y1 equal to a cos omega t. If you convert this as in terms of a, this capital A, of course, cos is converted into sin, it will become sin of omega t plus pi by 2. If you convert this as cos as sin, so here y2 will be, this is y2, okay, y2 will be a cos omega t converted as a sin omega t plus pi by 2, means first wave is lagging behind the second wave. First wave is lagging behind the second wave, or second wave leads first wave. Yes, first wave lag behind. First wave lag behind means less than pi by 2. How much angle? Pi by 2. First wave with respect to second wave means first wave lags behind second by pi by 2. Here plus is there. Second wave is more, first wave is less, means first wave is less than second wave by pi by 2. Okay, next question, 13th question. I will go to 13th question. Sorry. Once again I will wait. So I'll go to 13th question. The resultant of two waves, I'll read the question, 13th question. The resultant of two waves having amplitude B is B again. So the resultant of two waves having amplitude B is, again it is B, means there are two waves, they are of amplitude B and B, and the resultant is also B. Then the phase difference between the two waves is, the question asked is, what is the phase difference between the two waves? So for this, the resultant amplitude A equal to square root of individual amplitudes A1 square plus A2 square plus it is 2A1 A2 into cos phi, where phi cos phi is what? Phase difference. If all are equal to each other, if all means A1 is equal to A2 and resultant, that is also A, that is also equal to B. If you substitute this as B, this as B, this as B, all as B, then phi will be 120 degree. According to our resultant equation, if R equal to P equal to Q, if all the three are equal, then theta angle is 120 degree. This is the identity we have to use. So if all are equal, then the phase difference angle is 120 degree. Okay, so next I will move to next question. Which one? 14th question. If two antinodes and three nodes are formed in a distance of 1.21 angstrom, then the wavelength of the stationary wave is. See here, how many antinodes? Two antinodes. How many nodes? Three. For two antinodes and three nodes, we have to draw the waveform. See here, I will draw the waveform, stationary waveform. Here 1, 2, 3, three nodes. How many antinodes? Two antinodes. means two loops. Two loops means one wave. If two loops means one wave. One wave means one wavelength. One wavelength means 1.21 is the wavelength. So it is the total distance is 1.21 angstrom minute is given. It is given, means it is lambda. Lambda is 1.21 angstrom minute. This all the three antinodes, so three nodes and two antinodes makes two loops. Two loops means one wave. One wave means one wavelength. One wavelength is 1.21. It is given already. So direct answer is 1.21. ಅಂದರೆ ಇಲ್ಲಿಂದ ಇಲ್ಲಿಗೆ ಲ್ಯಾಂಬ್ಡಾ ವೇವ್ಲೆಂತ್ ಲ್ಯಾಂಬ್ಡಾ ಅಂದ್ರೆ ಡಿಸ್ಟೆನ್ಸ್ ಕೊಟ್ಬಿಟ್ಟಿದ್ದಾರೆ 1.21 1.21 ಲ್ಯಾಂಬ್ಡಾ. ಓಕೆ, ಸೊ ನೆಕ್ಸ್ಟ್ ಕ್ವಶನ್, ಐ ವಿಲ್ ಮೂವ್ ಟು ನೆಕ್ಸ್ಟ್ ಕ್ವಶನ್. ಫಿಫ್ತ್ ಕ್ವಶನ್, ದ ಫಂಕ್ಷನ್ sin square omega t, the function sin square omega t represents. So the function sin square omega t represents this fifth question. See here whether it represents a SHM with periodic time pi by omega. It is pi by omega. A SHM with a periodic time 2 pi by omega. It is a periodic equation, periodic motion with periodic time pi by omega, or it is a periodic motion with period 2 pi by omega. So which is the correct option? So the function sin square omega t, the function sin square omega t, it represents here the function sin square omega t represents. So here okay, see here it is y equal to sin square omega t. It is given, make it as omega. Okay, so if you rearrange the terms, it will be sin square is 1 minus 2 cos omega t, 1 minus 2 cos omega t, 1 minus 2 cos omega t by 2 cos omega t minus 2. If you cos square is what? 1 minus 2 cos omega t. If you separate and divide and you rearrange all the terms, the equation will be a. If you rearrange these terms, y will become directly proportional to a, means it is acceleration is directly proportional to displacement is directly proportional to acceleration with negative sign. It will come negative sign. Then time period, after comparing this, you will get the time period t equal to pi by a, pi by omega, not a, pi by omega. So it is an SHM equation with time period pi by omega. Pi by omega means this one. Option A is correct. It is a simple harmonic equation or simple harmonic motion with time period pi by omega. So option A is correct. Option A is what? Correct. So next thing, next question, 16th question. So if two almost identical waves having frequencies n1 and n2 produce one after the other superposes, then the time interval to obtain beat of maximum intensity is. So number of beats heard per frequency, number of beats per frequency is how much? Beat frequency fb equal to what is the formula for beat frequency? Difference of frequencies n1 minus n2, between frequency n1 minus n2. Time interval between two successive beats is time period is what? 1 by fb. 1 by fb means 1 by n1 minus 1 by n2, means which is the correct option? So time interval between two successive beats is what? 1 by FB, 1 by FB means 1 by N1 minus 1 by N2. So correct option is A. The correct option is A. Okay. So let us move to next question. Next question 107. Okay. See here, when two sound waves having amplitude A, angular frequency omega, it is omega, phase difference is pi by 2, not p by 2, pi by 2, superpose, then the maximum amplitude and angular frequency of the resultant wave is. If two sound waves having amplitude A, angular frequency omega, phase difference pi by 2, superpose on each other, then you have to calculate what is the maximum amplitude and angular frequency of the waves. Okay. So here phase difference between the two particles is how much? Pi by 2. If the phase difference between the two particles is pi by 2, they are oscillating perpendicular to each other. If they are oscillating perpendicular to each other, then the resultant wave is, the resultant amplitude is perpendicular, means A square plus what? A square. That means resultant amplitude is P square plus Q square. In that form, P square plus Q square means A square plus A square. It will be root 2 into A. So this is the resultant amplitude. Resultant amplitude is root 2 into A. Angular frequency doesn't change. It remains omega only. So option is, so again this is omega, this is omega, this is omega. So means option is amplitude is root 2A and angular frequency doesn't change when superposed. So option A is correct. So which is the correct option? Option A is correct. Okay, let us move to next question. So here the two waves are perpendicular to each other. Perpendicular means, once again I repeat, R equal to root of A square plus A square. A square plus A square means root 2A. Resultant amplitude is root 2A and angular frequency doesn't change, means omega remains omega. So option is root 2A into omega. So 108. Question number 108. The amplitude of a wave in a string is 2 cm. The amplitude of a wave in a string is 2 cm. This wave is propagating along x direction with a speed of 128 meter per second. With a speed of 128 meter per second. 5 such waves are accumulated. 5 such waves are accommodated in a 4 meter length of the string. 5 such waves are accommodated in a 4 meter length of such string. The equation of this wave is, see here, amplitude is 0.02. See here, then it is moving along x direction. It is moving along x direction means what? It is okay. It is moving along x direction means minus should be there, plus should not will come. B and D will cancel. Means minus C will A or C. A or C. 5 such waves are accumulated in a 4 meter length of string means see here, see here, speed is 128 meter per second. Speed is what? 128 meter per second. So omega equal to what? So V equal to what? Omega by K. It is how much? It is 128 meter per second. It is given. 5 such waves means 5 lambda. 5 lambda, it is accumulated in 4 meter length means 4. 5 lambda equal to 4. So lambda equal to 4 by 5. Lambda equal to 4 by 5 means K equal to, what is the value of K? K equal to 2 pi by lambda. 2 pi by lambda. 2 pi by lambda. So omega, using this 2 pi by lambda, K is 2 pi by lambda, substitute lambda value, you will get K as 7.85. You will get K as 7.85. K as 7.85 means omega t minus kx. Kx is like this, 7.85. 7.85x. 7.85x minus this will be 1005t. So correct option is C. Correct option is C. So here, so how I have calculated, once again I will repeat this question. So see here, the amplitude of the wave is 0.0. It is the amplitude of the wave is 2 centimeter. amplitude of the wave is 2 centimeter. It means that it is 0.02 meter. 0.02, all our amplitudes are 0.02, no change in the amplitudes. Next, the wave is propagating in along x direction. The wave propagates along x direction means the negative sign should be there. Negative sign means these two are correct, these two are wrong, so 50-50, 2 answers gone. Now the speed of the wave is 128, so v equal to omega by k, it is 128. Formula for v is omega by k. This 5 such waves means 5 wavelength. 5 such waves means 5 wavelength are located in how much length? 4 meter length. 5 lambda equal to 4. So lambda equal to 4 by pi. K equal to what? 2 pi by lambda. 2 pi by lambda. Substitute lambda as 4 by pi. Using this, I the k and the value of k will be 7.8. 7.8 is 7.85. So if 7.85, only c is of having 7.85. So omega t, it is kx. Kx means k value is 7.85 minus sign. So option C is correct. Okay. So let us move to the next question. Let us move to the next question. Which one? 109. Question number 109. Say a string of length. 70 centimeter is stretched between two rigid supports. A string of length, how much it is? 70 centimeter stretched between two rigid supports. The resonant frequency for this string is found to be 420 Hz and 315 Hz. Resonant frequency for this string is found to be 420 Hz and 315 Hz. If there are no resonant frequencies between these two values, find the value of maximum resonant frequency of the string. So here there are the resonant frequencies obtained for how many two frequencies? 315 and 420. Now Fn equal to what? Fn equal to resonant frequency. Fn equal to Nf1. Then what about Fn plus 1? Fn, it is given as 315. First one product frequency. The next one Fn plus 1. What about second frequency? Fn plus 1. Fn plus 1 is n plus 1 into F1. N plus 1 into F1. It means it is 420. It is how much? It is 420. It is given. First frequency 315, Nf1, first frequency. Second one n plus 1 F1. N plus 1 F1 means n plus 1 into, it is given 420. If you calculate Fn F1, F1 is Fn, what happens to this one? Now if you calculate Fn plus 1 minus Fn, Fn plus 1 minus Fn gives F1. Subtract these two. 420 minus 315, it will be 105 Hz. So answer is F1 final frequency, maximum final frequency is 105 Hz, means option C is correct. So option C is correct. Next question 110. How I calculated? Once again repeat. The string of length 70 cm support stretched between two rigid supports. The resonant frequency of this string is found to be 420 Hz and 350 Hz. If there are no resonant frequency between these two values, then what will be the minimum resonant frequency? Resonant frequency of the string. So we know that Fn is Nf1, Fn plus 1 is n plus 1 F1. F1 is 315 first initial, n plus 1 F1 is 420. There is no frequency between these two. So means Fn plus 1 minus Fn will be F1. F1 is subtract, it will get 105 Hz. Okay, so next question is the sound waves propagates with a speed of 350 meter per second through air with a speed of 3500 meter per second through the brass in brass. If the sound of wave having frequency 700 Hz passes from air to brass, then its wavelength is, okay. Now see here, the wave travels from one medium to another medium, that is from air to brass, then its wavelength decreases by fraction of 10, it increases by 20 times, it increases by 10 times, it decreases by fraction of 20. See here, the frequency doesn't change when a sound wave travels from one medium to another medium. So V equal to, general formula is F lambda. So F doesn't change, but lambda is directly proportional to velocity. If velocity increase from 350 to 3500, means wavelength has increased how much times? 10 times. The wavelength has increased how many times? 10 times. So option C is correct, because if velocity increases, wavelength also increases. If velocity increases, wavelength also increases. 350 becomes 3500, means velocity increased 10 times, means wavelength also increases by 10 times. So option, which one is correct? See here, sorry, 10 times the velocity, wavelength increases how much times? 10 times, means option C is correct. Okay. See here, for this, okay, if velocity is increased 10 times, then wavelength also increases by 10 times. So option C is correct. Okay. Okay students, continue with the questions on waves. So question number 1111111. Now I'll read the question. See here, a transverse wave is represented by the equation y equal to a sine omega t minus kx. For what value of its wavelength will the wave velocity be equal to maximum velocity of the particle? Means here simple concept is the wave velocity is equal to the maximum velocity of the particle. Wave velocity is how much? It is omega by k. Wave velocity can be written as omega by k, and maximum velocity of the particle is what? A omega, where A is amplitude. So from this omega get cancels. So what will be the answer? K 1 by k equal to A. So now we want wavelength. So 1 by k equal to A. What is k? K is 2 pi by lambda, but 1 by k will be lambda by 2 pi. So lambda by 2 pi is equal to what? A. Transfer 2 pi to this side, so you will get lambda equal to 2 pi A. So it is not P, it is pi A. It is pi A. It is also pi A by 2. So which is the correct option? A is the correct option, 2 pi A. Okay, so next I got, see here, 1 by k is A. 1 by k means lambda by 2 pi, because k equal to 2 pi by lambda. So 1 by k reciprocal is lambda by 2 pi. It is equal to A. So lambda becomes 2 pi A. Okay, next question. 112. Question number 112. Two monoatomic ideal gases 1 and 2 has molecular weights m1 and m2. There are two monoatomic ideal gases 1 and 2. They have molecular weights m1 and m2. Both are kept in two different containers. Both are kept in what? Two different containers, but they are at the same temperature. Temperature is same. What is the ratio of velocity of sound in the wave in the gas 1 and 2 is? So we know that velocity of a sound in a gas is written as square root of gamma into r into t divided by molecular weight m. So indicates V is inversely proportional to root m. That indicates velocity V1 by V2 for first gas to the second gas will be root of, reciprocal here means m2 by m1. So root of m2 by m1 is the correct option. It indicates option number A is correct. So I got here V equal to velocity of sound in a gas is square root of gamma into RT by m. So indicates velocity is inversely proportional to root m. It indicates V1 by V2 equal to root of m2 by m1. Okay, question number 112, option is A. Next move to question number 113. I'll read the question. A wire having length L is kept under tension between x equal to 0 and x equal to L. In one experiment, the equation of the wave and the energy is given by y1 equal to a sine, it is pi, a sine pi x by L sine omega t, and energy is what? E. This is the equation, and this is the energy E. If in another experiment, if y2 is a sine 2 pi x divided by L 2 sine omega t, and energy is what? E. Now you are asked to calculate what happens to E1 and E2 relation, energy for first one and energy for second one. So we know that energy, total energy is equal to half m omega square a square. This is expression for energy, and from this we can see that energy is directly proportional to omega square. Now here from pi x to 2 pi x, omega gets doubled from pi x to here pi x, here 2 pi x, omega has doubled. If omega is doubled, it is 2 square. It is, see here, omega gets doubled. Now omega gets doubled means it is 2 square. 2 square means it becomes what? 4. 4 means energy has become, E2 becomes 4 times E1. So energy has increased to 4 times, means E2 new energy, it is equal to initial 4 times the initial energy E1. So option C is correct. Okay, let us move to next question. Question number 114. Question number 114. I will read the question first. 24 tuning forks are arranged in such a way that 24 tuning forks. How many? 24 tuning forks. They are arranged in such a way that they produce how many beats? 6 beats with the preceding. Preceding means behind. Preceding fork. The frequency of the last tuning fork is double than the first tuning fork. Then the frequency of the second tuning fork is, preceding means next. Okay, I'm saying that preceding means next tuning fork. So one after the other, each tuning fork produces 6 beats. Suppose this is first tuning fork, this is second tuning fork. How many? Up to 24 tuning forks are there. 1, 2, and this is 24th tuning fork. From 1 to 24, each tuning fork difference is how much? 6 Hz. Each tuning fork frequency beat frequency 6 Hz means each tuning fork frequency difference will be 6 Hz. Now for first tuning fork should be double the 24th. For first tuning fork should be double the 24th, which will be the correct option for the second tuning fork. You are asked to calculate second tuning fork. So let me write the equation first. Frequency of the second tuning fork can be written as f2 equal to f1 plus 6. Second frequency is 6 more than first one, means f1 as it is, f1 as it is. I will write 6. Now I will write 6 as 2 second 4 minus first 4, 2 minus 1. If you multiply it, 2 minus 1 is 1, 1 into 6, it was 6. Similarly, write it for 24th tuning fork. 24th tuning fork, I will write it as f1 plus 6. Which tuning fork? f2 means 2, f24 means 24, f1 as it is minus 1 as it is. So if you calculate this by multiplying, this is 24, and if you calculate, you will get what? f1 plus 138, f1 plus 138. So but they given that frequency of 24th tuning fork f24 is double the first frequency tuning fork, double the first tuning fork frequency, means f24 is what? f1 plus 138, f plus 138, it is 2f1, means f1 value will be 138. If f1 is 138 from this equation, you can see, continue, f1 is 138. If f1 is 138, we want f2, second tuning fork. Question is asked for second tuning fork. f2 will be f1 plus 6, means 138 plus 6 means 144. So 144 is the correct option. Okay, once again I repeat, there are how many tuning forks? 24 tuning forks. They are arranged one behind the other. So each tuning fork gives how many beats? 6 beats with the preceding, means next frequency. So first and second beat frequency 6, means f2 can be written as f1 plus 6. f1 plus 6 can be written also as 6 into 2 minus 1. 2 stands for second tuning fork, 1 stands for first tuning fork. Similarly, f24 also can be written as f1 plus 6 into 24 minus 1. If you write this, you will get f1 plus 138. So f2, and given that f24 is twice 2f1, so f1 plus 138 equal to 2f1, so f1 is 138. If f1 is 138, then f2 is plus 6 more, means 144. They asked for second tuning fork, so 144 Hz. So next question is, if two SHMs are given by the equation y1 equal to 0.1 sine of 100 pi t, this pi not p, 100 pi t plus pi by 3, and y2 equal to 0.1 cos of pi t, then the phase difference between the velocities of the particle 1 and 2. Whatever the phase difference between y1 and y2, the same phase difference between velocity exists. If y1 and y2 phase difference, whatever it may be, the same phase difference exists between velocity of the particles v1 and v2. So let me calculate the phase difference between y1 and y2. If y1 is written as sine of 100 pi t plus pi by 3, y2 can be written as 0.1. Cos is converted into sine as sine of pi t plus pi by 2. Means if you compare y1 and y2, function sine is there, 100 pi t, here only pi t. Here phase is pi by 3, here phase is pi by 2. So if you take the phase difference delta pi can be written as, the phase of y1 is pi by 3. The phase difference means minus. The phase of second one is pi by 2. If you subtract these two, you'll get minus pi by 6. So answer is, so here this is pi, this is pi, this is pi, and this is also pi, means minus pi by 6 means D is the correct option. So next question. The wave number of a wavelength 0.05 meter, 0.005 meter is per meter, in per meter is, okay. So wave number nu bar, it is written as reciprocal of wavelength. If it is reciprocal of wavelength, it will be 1 by 0.005. If you do the calculation, what is the answer? It will be 200 per meter. 200 per meter. 200 per meter means option D is correct. Okay. So next question, 117. Question number 117. A listener is moving towards a stationary source of sound with a speed 1 by 4 times the speed of sound. What will be the percentage increase in the sound heard by the listener? Okay, see here, there is a listener stationary. Towards this listener, towards a stationary listener, the source is moving. The source is moving. Vs. So Vs is moving with how much velocity it is given? 1 by 4 times the velocity of sound. Now you are asked to calculate what is the percentage increase in the frequency of the sound heard by the listener. Okay, listener is stationary and the VL is 0. So if you count FL, frequency heard by the listener, FL is written as V minus 0. VL is 0. Thereby V minus Vs into real frequency. So velocity of sound is from source to observer. Velocity of sound is from source to observer. Comparison between V and Vs. If we compare V and Vs, see here, look at the equation. What happens to the equation? So here in this, listener is moving. Listener is moving. Listener is moving, and observer source is at rest. Source is at rest. So if we count this one, listener, source is at rest, and taken opposite, source is at rest, listener is moving. There is now VL, velocity of sound is from source to listener. So listener is moving and source is at rest. If we count that, FL is equal to V. See here, V. See, if you compare VL and V, they are opposite. If VL and V are opposite, it will come plus V plus VL divided by V minus 0 into real frequency. So if you count this, V plus VL, if V plus VL is how much? V plus VL is 1/4 of V, means V by 4 divided by V into F. If you count this, FL, so it will be 4V, means 5V, totally 5V by 4V means 5 by 4L, 5 by 4 into F. So FL is 5 by 4 into F, means now I have to calculate what percentage increase in the sound. Percentage increase in sound is, percentage increase is FL minus F divided by F into 100 percentage. FL minus F is, FL will be 5 minus F is 4 divided by 4 into 100 into 100. So if you count this as 1 by 400, 1 by 400 means 25%. So what is the percentage increase in the sound? Percentage increase in the sound is 25%. 20% means B is the correct option. Okay. Next one. When the resonance, here once again I will repeat, FL is what? V plus VL in V plus VL divided by V minus 0. Source is 0 into F. So V plus V by 4. VL is V by 4 into F divided by V. So if you count this, 5 by 4 F. So means FL minus F is 5 by 4 means 5 minus 4 divided by 4. 5 minus 4 by is 1 by 4. It is into 100 means 25%. So question number 117 option is 25%. So let us move to the question number 118. When the resonance tube experiment, to measure the speed of sound is performed in winter. The first harmonic is obtained for 16 cm for air column. If the same experiment is repeated in summer, the second harmonic is obtained for x length of the air column, then which option is correct? For this I will first erase this all. Then I will go for the question number 118. So okay, now see here, when resonance tube experiment is done to measure the speed of sound in winter season, the first harmonic is obtained at 16 centimeter. So first harmonic is obtained at what? 16 centimeter. If of the air column. If the same experiment is performed in summer, the second harmonic is obtained to be x length of the air column. Then okay, as we know that the velocity of sound is directly proportional to the square root of temperature. From winter to summer, temperature increases. If temperature increases, velocity also increases. If temperature increases, the velocity of sound also increases. In winter, I will calculate winter. In winter, second harmonic is F1 equal to x. Second harmonic will be x equal to 3L1. See here, 3L1 means what? 3 into 16. In winter I am calculating. I am not going for summer. In winter, first harmonic is 16 centimeter. Second harmonic will be 3 times the initial, means 3L. 3L means 48 centimeter. So 48 centimeter is what? It is the second harmonic in winter. 48 is what? 48 centimeter is what? It is the second harmonic in winter. 48 centimeter is for second harmonic in winter. If from winter to summer, if temperature has increased, then definitely x also for summer, second harmonic, x distance, what upon, see, compare 48 centimeter x, which will be great? Winter 48 is more or summer x is greater. So if from winter to summer, if temperature has increased, then definitely length also increases because velocity of sound has increased. Means x should be definitely greater than 48. Means option C is correct. Okay, let me repeat this question. In winter season, the first harmonic is 16 centimeter. But in the same winter season, what should be the second harmonic? Second harmonic is 3, not 2L, because in air column the odd harmonics are present. 1L, 3L, 5L, like this. 1L is first harmonic, 3L is second harmonic, 5L will be third harmonic. So second harmonic means 3L, means 48 centimeter is for winter season. But for the summer season, the second harmonic For the same second harmonic in summer season, the distance is x, means from winter to summer, temperature is increased, means the balancing length or the resonating length also must increase, means 48 to x will increase, means x must be greater than 48. Okay, so with this I will move to next question. Now 119, question number 119. What should be the speed of source of sound moving towards a stationary listener, so that the frequency of sound heard by the listener is double the frequency of sound produced by the source? Okay, where speed of sound is v. Okay, now what should be the speed of source of sound which is moving towards stationary listener? I'm going to write here source moving towards a listener which is at rest, not moving. Velocity of sound is taken from source to listener. Now, so that here frequency of the sound heard by the listener is double the frequency of sound produced, means FL is what? Frequency heard by the listener is double the real frequency. So FL can be written as, here the FL can be written as V minus 0 divided by V. Here source is along the velocity of sound. Source is along the velocity means minus sign remains as it is. Vs into bracket F, it is equal to what? 2F. It is given 2F. FF cancels. So what remains? V divided by V minus Vs equal to 2. If you compare this, multiply on both sides, V equal to 2V minus 2Vs. Take Vs to that side. So what happens? 2Vs will be equal to V, or Vs equal to V by 2. So Vs is what? V by 2. Option C is correct. So Vs is what? V by 2. Option C is correct. Okay, so next question, 120th question. So before going to solve 120th question, I will erase some of the part because I want to write the solution. So that's why I am erasing these all. Okay, now I will move to the question number 120. Question number 120. Okay, I'll take the pen. Okay, first I will read the question. Question number 120. I will read the question. See here. A metal wire having linear mass density 10 gram per meter. Linear mass density is how much? 10 gram per meter, is passed over two supports separated by a distance of 1 meter. The separation between the two supports is 1 meter. The wire is kept in a tension by suspending a 10 kg mass. The wire is suspended by suspending a tension of how much? 10 kg mass. The midpoint of the wire passes through the magnetic field provided by the magnets, and an AC supply of having frequency N is passed through the wire. What is the frequency of the source? N. It is passed through the wire. If the wire starts vibrating with its resonant frequency, what is the what is the frequency of the AC? So simple technique is the frequency of AC is equal to resonant frequency. The frequency, I write here, the frequency of AC is equal to the frequency of the wire. Frequency of the AC is equal to frequency of wire. The frequency of AC F equal to N. N is frequency of the wire. N can be written as what? N can be written as 1 by 2L into root of t by m. Root of t by m. Now calculate 1 by 2l. 1 by 2l. What is the length here? 1 meter. 2l length, distance between the two wires is 1 meter into l is 1 root of t. T means 10 kg. 10 kg means t is equal to mg. M mass into gravity. Gravity is also 10 because g is 9.8. T equal to what? I'll write here t equal to, see here, I will write here t equal to mass into gravity. Mass into gravity. Mass is how much? 10. It is also 10. So 10 into 10 it is. Divided by mass per unit length. So what is mass per unit length? It is 10 gram per meter. Means it converted into kg means 10 into 10 raised to minus 3. So it will be 1 by 2 as it is. 2 into 1 is 2. Square root of 110 get cancels. 10 raised to minus 3 goes to the numerator, becomes 10 raised to plus 3. 10 raised to plus 3 into 10, it will be 10 raised to 4. So when you remove the root here, it will be 1 by 2 into 100. So 1 by 2 into 100 will become what? 100 by 2. 100 by 2 means 50 hertz. So what is the answer? 50 hertz. So simple technique behind this problem is the frequency of the AC is equal to frequency of the wire. So we know the frequency of AC F is equal to N. N is the frequency of wire. N is what? 1 by 2L into root of T by M. Answer calculating T, M, substituting T and M and L, will get what? 50 hertz. Okay. Okay. Next question is question number 121. If the listener and the source of sound, question 121, if the listener and the source of sound moves along the same direction with the same speed, then, so here the listener and the source of sound moves along the same direction with the same speed. If the listener and the source of sound moves in the same direction, it indicates that the listener and source, between the listener and the source there is no relative motion. So here I will draw the diagram. The source and the listener, both move along same direction with same speed, means there is no relative motion between the source and listener. There is no relation between the source and the listener. If there is no relation between the source and the listener, then frequency of listener is equal to the frequency of the source. Means Fs is equal to Fl or Fl equal to Fs. If Fl equal to Fs, the ratio of Fl and Fs becomes equal to 1. So correct option is what? C. Why Fl by Fs equal to 1? Fl is the apparent frequency of listener. Fs is the true frequency of source. When there is no relative motion between the listener and source, the frequency of listener is equal to true frequency of source, means Fl equal to Fc. If Fl equal to Fc, Fl by Fc is equal to Fl by Fs equal to 1. Okay, question number 121, answer is C. Next question 122. A wire of length 10 meter. There is a wire of length 10 meter and its mass is 3 kg. And its mass is how much? 3 kg. It is suspended. It is suspended from a rigid support. It is suspended from rigid support. The wire has uniform cross-sectional area. It is given that the wire has got uniform cross-sectional area. Now when a block of mass 1 kg is suspended at the free end of the wire, the block of mass 1 kg is suspended at the free end of the wire, and a wire and a wave having how much length? A wave having length 0.05 meter is produced at the lower end. A wave of length how much? 0.05 meter is produced at the end, 0.0 produced at the lower end. What will be the wavelength of this string when it is reached at the upper end? This is a question. So I will draw the picture here. There is a rigid support. Now there is a rigid support. From this rigid support, the wire is suspended. The wire is of thick weight and it is uniform cross sectional area. It is given uniform cross sectional area. The wire is suspended here. If the wire is suspended with a load of how much? 1 kg. So at the upper end, this is upper end, this is lower end. So what is the weight at the lower end? It is equal to mass. So tension at the lower end, tension at the lower end T1. Tension at the lower end, I will write here, tension at the lower end, it is because of block of mass. How much it is? 1 kg. I will write M1 G. M1 is 1 G means G. T1 equal to 1 G. That is tension at the lower end. Now, what is the tension at the upper end? Tension at the upper end is denoted as T2. So I will write T2 as, see here, the tension at upper end will be the mass of the string as well as mass of the block. Mass of the block is M1 plus mass of the string is M2 into G. So what happens here? M1 is 1 kg. M1 is 1 kg plus M2 is 3 kg. M2 is 3 kg. So totally what happens here? 1 plus 3, it is G. 1 plus 3 into G. It will be, how much it will be? T2 equal to, tension at the upper end will be 4G. Tension at the lower end is 1G. So we know that tension varies from lower end to upper end. Here tension at the lower end is 1G. Tension at the upper end is T2 is 4G. Now we know that here now wavelength at lower end is 0.05 meter. Wavelength at upper end is, you have to calculate wavelength at upper end. So we know that velocity is directly proportional to root of tension and further it is proportional to wavelength. So velocity is directly proportional to root of tension and it is directly proportional to what? Wavelength. Using this concept, if you calculate V proportional to lambda, V proportional to lambda means lambda proportional to root t. So if you generalize this one, lambda 1 divided by lambda 2, it is equal to, what happens, it is root of T1 divided by T2. So T1, root of T1 is what? G. Root of T2 is 4G. So what happens here? It will be 1 by 2 it will be. So we got lambda 1. Lambda 1 is 0.05 meter. Wavelength at lower end 0.05 meter. Wavelength at upper end. So lambda 2 is equal to 2 lambda 1. 2 lambda 1 means 2 into 0.05. 2 into 0.05. It will be 0.1 meter. So option is 0.1 meter means option is D. Option is D. See here how I calculated this here. Very simple concept here. So there is a wire, thick wire of mass 3 kg suspended by a block of mass 1 kg. Now here the wave is produced at the lower end. How much is the wavelength of the wave? 0.05 meter. So calculate the tension in the lower end. It is denoted at T1. T1 is M1G, mass of the block into gravity. Tension at the upper end, T2. T2 equal to mass of the block plus mass of the whole wire. Mass of the whole wire will contribute at apparent tension. Mass of the whole wire plus block gives tension at upper end, that is m1 plus m2 into g, 1 plus 3 into g, it is 4g. We know that velocity is direct proportional to root of tension and is further proportional to lambda. So it implies lambda 1 by lambda 2 equal to root of t1 by t2. Substitute, you will get lambda 2 as 0.1 meter. Okay, it is option D. Okay, next question. I will read this next question. If a mass of 1 mole of air is 29 into 10 raised to minus 3 kg, then the speed of sound in air at STP is. So simple concept, the speed of sound in at STP is near about 330 meter per second. So option is 330. So the velocity of sound at STP is 330 meter per second. So option C. No need to go for calculation. Okay. After this, next question. A wave traveling along a string is described by 124. Question 124. A wave is traveling along a string. It is described by the equation y equal to 0.005 sine of 40x minus 2t in SI units. The wavelength and frequency are. So it is in the form of omega t minus kx or kx minus omega t form. Kx minus omega t form. Here k is what? K is 40. K is 40. K is 40 and omega is 2. K is 40 and omega is 2. Now we have to calculate wavelength and frequency. If k equal to 40, k wave formula is 2 pi by lambda equal to 40. K pi by, it is k by 2 pi by lambda into 40. Now lambda will be lambda equal to 2 pi by so it goes here, it is here 2 pi by 40. If you do the calculation, it will be 2 pi by 40 will become pi by 20. So wavelength of the wave is 2 pi by 20. So which is the correct option here? Wavelength is pi by 5. Pi, it is pi, not pi. P. Pi by 5, it is not. The wrong answer. Pi by 10, no. Pi by 40, no. Pi by 20. So pi by 20 is the only one option, that is D. So frequency will be 0.32 hertz. No need to calculate the frequency. Why? Because pi by 5, pi by 10, pi by 40, pi by 20. So which is the correct option? Pi by 20. D is the correct option. Okay, so we move to next question. That is 125. Question number 125. Read the question. So two strings A and B. There are two strings A and B playing the note dha. The two strings playing the note dha are slightly out of time. They are slightly out of time and produce beats of frequency 5 Hz. They produce how much beats frequency? 5 Hz. The tension in the string B is slightly increased. Now the tension in the string is increased means frequency of the B also increases. Now the beat frequency is found to decrease to 3 Hz. Beat frequency reduces to 3 Hz. What is the original frequency of the B? A frequency is 427 Hz. Okay. We use the concept of beats to calculate the frequency of B. We know that initial beat frequency is how much? 5 Hz. Frequency of A is what? Frequency of A is what? 427 Hz. Frequency of A is 427 Hz. Then what is the possibility of frequency of B? It is plus 5 or minus 5. Plus 5 means 432 add 5, or 4 minus subtract 5 422. So what are the possibilities of the frequency of B? Either 432 or 422 because beats are 5. ಮೊದಲಿಗೆ A and B play ಮಾಡ್ತಾರೆ. A and B play ಮಾಡಿದಾಗ A frequency 427, B frequency ಏನಾಗಬಹುದು 5 Hz ಹೆಚ್ಚಾಗಬಹುದು, 5 Hz ಕಮ್ಮಿ, ಅಂದರೆ 432 or 422. Now if you increase the tension in the string, B tension is increased means FB increases. FB increases. If FB increases, beat frequency becomes 3 Hz. New beat frequency becomes what? 3 Hz. Now take here, if you take 432, beat frequency reduces. Beat frequency reduces means here if here tension in the string is increased, beat frequency of B increases, and the 432 in the ಹೆಚ್ಚಬೇಕು and the 432 or 433 or 434. So if you play 432 above frequency with 427, you will never get 3 Hz beat. ಅಂದ್ರೆ ಏನಾಗುತ್ತೆ, ಬಿ ಫ್ರೀಕ್ವೆನ್ಸಿ ಹೆಚ್ಚು ಮಾಡೋದ್ರಿಂದ ಆನ್ ಇನ್ಕ್ರೀಸಿಂಗ್ ದ ಫ್ರೀಕ್ವೆನ್ಸಿ ಆಫ್ ಬಿ ಫ್ರೀಕ್ವೆನ್ಸಿ ಇನ್ಕ್ರೀಸ್ ಬಿಕಾಸ್ ಟೆನ್ಷನ್ ಈಸ್ ಇನ್ಕ್ರೀಸ್. Means if you take 432, the frequency will be above 432, means it may be 433, 434, 435. If you take any frequency above 432 and beat, if you sound it with 427, you will never get 3 Hz. Means 432 is not possible. So if you take 422 Hz, if you take 422 Hz and increase the tension in B, 422 will increase. It may go to 424. When it goes to 424, above 424 and you play with 427, 424 and 427 gives 3 Hz beat. So means 422 is the correct option. Okay, so this is the logic of beats to calculate the beat frequency. So to calculate the unknown frequency. Okay, so once again I repeat, there are two strings A and B. They produce a note dha slightly out of order and produce what? A beat frequency 5 Hz. The frequency of A is given 427. Then what should be the possible frequency of B? Either plus 5 or minus 5. Plus 5 means 432, minus 5 means 422. 5 plus ಮಾಡಿ 5 minus ಮಾಡಿ, ಇವೆರಡರಾಗ ಒಂದು ಯಾವ ಸೆಲೆಕ್ಟ್ ಮಾಡೋಣ? ಈಗ the tension in the string is slightly increased, then beat frequency reduces to 3 Hz. ಈಗ ಟೆನ್ಷನ್ ಇನ್ ದ ಸ್ಟ್ರಿಂಗ್ ರೆಡ್ಯೂಸ್ ಮಾಡಿದಾಗ ಬೀಟ್ ಫ್ರೀಕ್ವೆನ್ಸಿ 5 ಇಂದ 3 Hz ಬರುತ್ತೆ ಬೀಟ್ ಫ್ರೀಕ್ವೆನ್ಸಿ. when the tension in the B is increased, the frequency of B also increases. That is the concept. So if you take 432, tension increases, frequency also increases, means 432 above is 433 or 434 or 435, any value. If you play with the 432 above value with 427, you will never get 3 Hz. So that's why better to take below frequency, that is 422. If 422 is increased to 424, then 424 and 427 beats produces 3 Hz. Means what is the possible answer? 422. Okay. Okay. So continue with the next question. Question number 126. So I will read the question first. So question: a rocket is moving with a speed of 130 meter per second towards a stationary target. Rocket is moving with 130 meter per second towards the stationary target. While moving, it emits a wave of frequency 800 Hz. Calculate the frequency of sound as detected by the target. So very simple concept of this problem. So there is a source. This source emits. This source is moving towards a stationary listener or observer. Listener is stationary. So this is the source is moving. Now if the source is moving with a speed of 130 meter per second, now you are asked to calculate the apparent frequency heard. So formula for the apparent frequency heard by the source is Fs equal to what is the formula? Sorry, not Fs, Fl. Fl equal to and write the formula. Fl equal to the formula here. Fl equal to V minus 0. Listener is at rest, divided by V minus Vs. Source is moving towards the listener, means V minus Vs into Fs, real frequency of the source. Using this formula, substitute V as 330, Vs as 130, Fs as 800. Do the calculation. That is 330 minus 0. Here 330 minus 0 divided by 330 minus 130 into 800. That will lead to give the answer as 1320. So what is the option here? 1320. So FL will come as 1320. So here how to calculate? Formula is FL equal to V minus 0. What is Y 0? VL is 0. Listener is at rest. V minus VS into FS. V is 300. 330. 0. 330 minus VS 130 into FS 800. You will get 1320. Okay. So option A is correct. Okay. Next question. Next question is, if the length of a steel wire is 11 meter. Question 127. The length of the steel wire is 11 meter. The length of the steel wire is 11 meter and its mass is 2.2 kg. Its mass is 2.2 kg. What should be the tension in the wire so that the speed of the transverse wave in it is equal to the speed of sound in dry air at 20 degrees centigrade. The speed of sound in air at 20 degrees centigrade. Okay, so the length of the steel wire is given. The length of the steel wire is 11 meter and its mass is 2.2 kg. What about its mass? 2.2 kg. What should be the tension in the wire so that the speed of the transverse wave is equal to speed of sound in dry air at 20 degrees centigrade? See here, we know that velocity of a wave is equal to root of T by mu, where mu is mass density. Now calculate T here. Tension is the string formula. T equal to, it will be V square into mu. So V square as it is, mu is what? M mass per unit length, M by L. Now T we got it as V square into M by L. But what about V, velocity of sound for the transverse wave? The velocity of the transverse wave is equal to speed of sound in air at 20 degrees centigrade. See here, speed of sound at 0 degree centigrade is, how much here? Speed of sound at 0 degree centigrade is, we know that it is 330 approximately 330 meter per second. For every 1 degree centigrade rise, the speed of sound increases by 0.6 meter. For every 1 degree centigrade, per degree centigrade rise, how much is the rise in temperature? 0.6. Now for 20 degree centigrade, how much is speed of sound? For 0, 330. For every 1 degree centigrade, 0.6 will rise. Mean 0.6 into 20. 1 degree, 0.6. 20 degree centigrade, 0.6 into 20 means it is 12 meter per second increase. 12 meter per second increases. And totally if you count the velocity at 20 degrees centigrade, is 330 plus 12, that is 342. So velocity of sound at 20 degrees centigrade is 342. So velocity of sound or speed of sound at 20 degrees centigrade is equal to speed of transverse wave. It will be, so T equal to here V square. What should be V square? It is V20. V square equal to V20. V20 means 342. So 342 square into M by L. M by L means M is 2.2 divided by 11. After doing the calculations, the tension in the string will be, tension in the string will be 2.31 into 10 raised to 4 Newton. So how you have calculated this tension in the wire? So tension in the wire for formula, velocity of the transverse wave equal to root of T by M, tension in the wire into mass per unit length divided by mass per unit length. So T equal to V square into mu. So square and transfer mu to this side. V square into mu. V square into mu means mass per unit length, m by L. But we don't know velocity of the transverse wave. But velocity of the transverse wave is equal to the speed of sound at 20 degrees centigrade. So how to calculate the speed of sound at 20 degrees centigrade? Now approximately the speed of sound at 0 degrees centigrade is 330. Approximately it is 330. It is 332. It is 332, but approximately 330. Now for 1 degree centigrade height it is 0.6 rise. How much is the speed of sound increases? For 1 degree centigrade it rises by 0.6. Remember this concept every time. So totally 0.6 into 12. So 0.6 into 20 degrees centigrade rise. So 0.6 into 20 becomes 12. So add this 330 to 12. So it will become velocity at 20 will be 342. So velocity at 20 degrees centigrade is the velocity of the transverse wave. Substitute here, do the calculation. That is mass per unit length m 2.2 by L 11. You will get 2.31 into 10 raised to 4 Newton. Okay. So question 127, option A is correct. Okay. Next question number 128. What is question number 128? A wire is stretched between two rigid support, vibrates with a frequency of 45 Hz. The wire is stretched between two rigid supports, vibrates with a frequency of 45 Hz. If the mass of the wire is 3.5 into 10 raised to minus 2 kg and its linear density is 4.0 into 10 raised to minus 2 kg per meter, what will be the tension in the wire? So you have to calculate the tension in the wire. So here to calculate the tension in the wire, you must know the here I will erase this first, then I will take. Okay, you see here the stretched wire is stretched between two rigid supports. Frequency gives 45. Frequency is 45. Now frequency of a stretched string is given as F equal to 1 by 2L into root of T by m or mu. You can say m or mu. Okay, I want tension in the string. Tension in the string T equal to, so what is the answer? If you square this, 4 F square L square divided by or into mu it will be. So 4 F square I will write as it is, L square as it is. Mu is m by, so here mu is already given, but how to write L? 4 F square, L is written as, so since mu equal to m by L, so L can be written as m by mu into this mu, and it is square here. So totally the formula reduces to T equal to 4 F square m square, capital M square, mass, mu square into one more mu up to the numerator. So one mu, this mu cancels. So what happens to the tension in the string? Tension in the string will become equal to 4 F square m square divided by mu. So remember this formula. If mass of the wire and density of the wire are given, what is the tension in the wire? T equal to 4 F square m square divided by mu. So substitute the values. 4 F square means 45 into 45 means 45 square into m square. M is mass of the wire. Mass of the wire is 3.5 into 10 raised to minus 2 kg, which is square divided by mu. Mu is how much? 4 into 10 raised to minus 2. So after doing the calculations of this one, 4 into 45 square into 3.5 into 10 raised to minus 2 whole square divided by 4 into 10 raised to minus 2. So you will get the answer as 248 Newton. So what is the option here? 248 Newton. So how you got here with the formula of F 1 by 2L into root of T by mu, T equal to 4 squaring on both sides 4F square L square mu, 4F square L square mu, as it is 4F square L can be written as m by mu. So m by mu into whole m by mu whole square into mu. M by mu whole square means m square by mu square 1 mu cancels, so what remains 4f square m square divided by mu. Substitute, you get the answer as 248 Newton. Okay, so next, move to next question. A tube A has both end open while the tube B has one end closed, means A is open at both end, means it is open pipe. A will be open pipe. B is closed at, if B is closed at one end, open at other end, it will become closed pipe. So now clear, A is open pipe, B is closed pipe. Otherwise they are identical, means remaining factors are same. The ratio of fundamental frequency of tube A to tube B is, the ratio of fundamental frequency of tube A to tube B. So frequency, fundamental frequency of tube A means open pipe, FA can be written as V by 2L. V by 2L. Similarly, frequency of B, which is a closed pipe, the frequency of B is written as V by 4L. Now V by 2L, V by 4L. Now divide the two. When you divide the two, VA by VB, so VA by VB, you will get 2:1. Or so you are asked to calculate fundamental frequency FA by FB, not VA by VB, FA by FB. FA by FB, it is equal to V by 2L whole divided by V by 4L. So V cancels, L cancels, 4 goes to the numerator, 4 by 2 means 2:1 is the correct option. Okay, so next question, move to next question. So 130, question 130, a tuning fork arrangement produces 4 beats per second with one of the fork of frequency 280 Hz. There is an unknown frequency FU, there is an unknown frequency FU, I am going to write, there is a known frequency that is equal to 288, it is given 288. A little wax is applied to the unknown fork. Whenever a wax is applied to any fork, its frequency decreases. Remember, waxing and filing. Waxing reduces the frequency. Filing means cutting the stem. Filing increases the frequency. Here waxing is there, so frequency of the fork decreases and beats becomes 2. Beats also reduces. What is the frequency of unknown? Now here, what are the possibility of unknown frequencies? 280 is the known frequency. If you sound it to with 4 unknown frequency, 4 beats are heard. Possible frequencies are 288 plus 4 means 292, or another 288 minus 4 means 284. So what is the possibility answers for unknown frequency? Either 292 or 284. 284. So out of this one, 284 is absent. 284 is absent. So 292 is the correct option. So 284 is absent. So correct option is what? 292 Hz. So 130 option is B. Next question. A wave y equal to a sin omega t minus kx. It is omega t minus kx on a string meets another wave producing a node at x equal to 0. Then the equation of the unknown wave is, what should be the unknown equation of the unknown wave? In this here, there is a wave which moves along the string. There is a wave which moves along the string. What is the equation of the wave? Y equal to A sine omega t minus kx. So to produce the node means stationary wave. To produce a stationary wave, another wave should come opposite. If another wave should come opposite, the equation of wave must be y equal to A sine omega t minus will become plus kx. So if stationary waves, if the case is only stationary wave, we have chosen plus kx. But the at x equal to 0 initial point, the node should be produced. For x equal to 0 to node should be produced, the wave should have two properties. The wave should travel opposite. And it should have opposite phase. If for opposite phase it should have negative sign, means minus. Means there should be two properties for the upcoming wave. One wave along x-axis, another wave should be along negative x-axis, it should come opposite. Another property of that wave should be, it should have opposite phase to produce the node, and the wave should cancel each other. Opposite phase means it should cancel each other and the node will be produced. So there will be two properties for the upcoming wave. That means it should have opposite means negative sign becomes plus. It should have opposite phase also. Opposite phase means it should be negative sign, means correct option is B. So once again I'll repeat this question. There is a wave which is moving along the string which meets another wave. That another wave should have produced node. Node means at x equal to 0. Node means stationary wave, and it should produce node. For node and stationary wave production, the unknown wave should have opposite direction, and the unknown wave should have opposite phase also. Unknown wave opposite direction means minus becomes plus. Opposite phase means plus becomes minus here. Minus y equal to minus a means opposite phase. This plus becomes opposite direction. So both properties for second option. So that's why the option B is correct. So if you next question, when the temperature increases, see here question, when the temperature increases, what happens to the frequency of the tuning fork? If the temperature increases, the frequency of the tuning fork. So temperature Nt equal to frequency at T degree centigrade equal to frequency at 0 degree centigrade 1 minus 0.0001 into T degree centigrade. See here, using this formula, if the temperature increases, the term increases in negative value. If the term increases in negative value, the frequency will decrease. So frequency will decrease. See here, relation between Nt and N0. Nt means frequency at T degree centigrade. N0 means frequency at 0 degree centigrade. So Nt equal to N0 into 1 minus 0.00001 into T. If temperature increases here, this whole term increases, but it increases in negative. If it increases negative, Nt will decrease. So option B is correct. Okay. So next we move to the next question. Question number 133. So I'll read the question first. A tuning fork of unknown frequency 256 Hz makes 5 beats per second. There is a tuning fork 256 Hz beats, produces 5 beats with a wire vibrating string of piano. With piano, how much beats are produced? 5. With how much frequency? 256. So what should be the frequency of piano? Fp equal to, it should be 5 more or 5 less. 5 more means 261 or 5 less means 251. So how much beats are produced? 5. So what is the frequency of the known one? 256 means 261 or 251 is the answer. The beats frequency decreases to 2 beats when the tension in the piano string is slightly increased. When the tension in the piano string is increased, so Fp also increases. Fp increases means here beats also increased. Fp increases, beats will decrease. From 5 beats to beats will decrease to 2 beats. Now if you take 261 as the answer, if you increase the tension, the frequency will increase beyond 261. If it increases beyond 261, so options will be 262 or 263 or 264. Let us take 262. If you take any number 261 beyond, it will not produce 3 beats with 256. So 261 is wrong assumption. So if you take 251 as the frequency of piano and you increase the tension, if you increase the tension of piano, beat frequency, so frequency increases means it goes 251 above. 251 above means it goes to 250, 253. When it becomes 253 and sounded with 256, sorry, not 253, 254. When you increase the frequency of piano by increasing the tension, it becomes 254. 254 and 256 will produce 2 beats. Means 251 is the possible answer. For 251 we should have 256 minus 5. 256 minus 5. So option C is correct. Once again I will repeat this question. There is a known frequency 256 which produces 5 beats with piano. So piano answer should be 261 or 251 plus 5 or minus 5. Now if the piano string is tension is increased, piano frequency increases, then beats will reduce to 2. Means if you take 261 as your assumption, if you increase the piano frequency, it will be 261 above. If you take any number 261 above, it will not have difference with 256 as 2. 261 above ಯಾವುದೇ ನಂಬರ್ ತಗೊಂಡು 256 ಜೋಡಿ ಡಿಫರೆನ್ಸ್ ತಗೊಂಡ್ರೆ 2 ಬರೋ ಪಾಸಿಬಿಲಿಟಿ ಇರಲ್ಲ. ಸೊ ಅದಕ್ಕೆ ಏನು ಮಾಡಬೇಕು, 251 ಈಸ್ ದ correct option. If you take 251 as the piano frequency and slightly increasing frequency, it becomes 254. 254 and 256 produces 2 beats. So possible answer is 251. 251 can be written as 256 minus 5. So correct option is C. Okay, question number 134. So I will read the question. An observer moves towards a stationary source of sound. So means here there is a source, here there is a source, the listener, or you can say observer, both are same, VL or VO. The listener or observer moves towards the stationary source. So V is this source to our listener, direction of velocity of sound is from source to listener. So here the velocity of the listener is 1/5 of the source of sound, and what you are asked to calculate the apparent percentage increase in the percentage of sound. Now for this FL can be written as V, okay, minus. So minus means here minus of minus plus. Why? Because VL is opposite to V, means minus of minus plus, that is VL plus V plus VL divided by V minus 0. Velocity of source is 0 into Fs. So if you take the ratio FL by Fs equal to V plus, what is VL? It is V by 5, 1/5 of the sound. So V by 5 divided by whole V. Now take the LCM, it will be 6V by 5V, means V cancels, it will be, ratio will be 6 by 5. If it is 6 by 5, the percentage increase in the frequency of sound is FL minus Fs divided by original frequency Fs into 100. So ratio of FL by Fs is 6 by 5, means it will be 6 minus 5 divided by 5 into 100. So what should be the answer? 1 by 5 into 100. 1 by 5 into 100 is, what is answer? 20 percentage. So how much is the increase in frequency of the apparent frequency of the sound? It is 20 percentage. Option B is correct. Okay, so this is next week for the next question 135. Question number 135. See here, the speed of sound in oxygen is O2 at certain temperature is 460 meter per second. The speed of sound in helium at the same temperature will be. So here we have to calculate the speed of sound in oxygen is given. The speed of sound in oxygen is given. Now you have to calculate the speed of sound in what? Helium. So to calculate this, velocity of sound in oxygen can be written as V equal to VO. I will write it as VO equal to gamma RT divided by molecular weight M. Molecular weight of oxygen is 32. Now here, what is the formula for helium? So if you substitute VO, velocity of sound in oxygen, VO equal to square root of, for oxygen gamma is 1.4, RT is constant, leave it, RT is a constant, divided by temperature is same, R is universal constant, M. Molecular weight of oxygen is 32. This will be VO equal to 1.4 by 32. For helium, it will be VH equal to helium. Again, gamma for helium is 5 by 3. 5 by 3. Again, RT is constant and 1 by M. M is molecular weight of helium. Molecular weight of helium is 1 by 4. So if you divide these two, VO by, so VHE by VO equal to, so what happens here? It will be root of 5 by 3 into 1 by 4 whole divided by, it is 1.4 divided by 32. On solving this, you will get VHE as 1 3, it will be order of 1420 order. If there is no option 1420, so D is the correct option, none of these. So how you have calculated? Velocity of oxygen is root of gamma RT by M. VO equal to gamma value is 1.4. I have not written RT. Why I have not written RT? RT is a constant, divided by M. M is what? 32. Or you can write your proportionality sign here instead of equal to proportionality. So VHE is proportional to gamma. Gamma is 5 by 3. M is 1 by 4. M is 4. So it is 1 by M means 1 by 4. VO is proportional to root of 1.4 by 32. VHE is proportional to root of 5 by 3 into 1 by 4. Divide VHE by VO means root of 5 by 3 into 1 by 4 divided by root of 1.4 into 32. 1.4 divided by 32. On solving this and multiplying with VO is how much? 460. Multiply this whole term with 460. You will get 1420, which is not present. So option is none of these. Okay. So next thing, we move to next question. Question 136. In a longitudinal wave, the pressure variation and displacement variation are. In a longitudinal wave, the pressure variation and the displacement variation are. In a longitudinal wave, pressure is maximum when displacement is minimum. Means pressure becomes maximum. In that case, displacement becomes minimum. Y becomes minimum. Means these are out of phase. These are out of phase means 180 degree out of phase. So option D is correct. In a longitudinal wave, if pressure is maximum, displacement is minimum, means both are out of phase with 180 degree opposite, means D is correct option. Let's move to question number 137. There is a tuning fork of frequency 480 Hertz. There is a tuning fork of frequency 480 Hertz. It produces how many beats? 10 beats with a sounded when sounded with a vibrating sonometer wire. So here unknown frequency, so there is a known frequency f equal to 480. The known frequency is 480. Unknown frequency will be when you sound it with the 480, the frequency of sonometer that is unknown. Sonometer wire is unknown. It produces 10 beats, means possible answers are either plus 10 means 490 or minus 10 means 470. So options will be either 490 or 470, means B or D. No A and C. So if when the same wire is, if the string is slightly increases, frequency of the string slightly increases, tension produces, when the increase in tension produces the frequency of the string increases, it produces fewer beats and less beats are produced, means beats are decreased. So the same concept, to decrease the beats, we have to select either 490 or 470. So the best answer is what? 470 is correct, because whenever if you take 490 as your option, and if the tuning fork frequency increases, means beyond 490 it increases, either 491 or 492 or 493. Any number 490 above will not produce less beats with 480 less than 10. So if you take 491, the beats will be 11. 492 beats will be 12. So that's why. So which will be option? 470 is the correct option. 470 assumption, 490 assumption, 470 is correct assumption. Why 470 is correct assumption? 470 is correct assumption because when you sound this unknown frequency and increases frequency 470 above 472 or 473, the beats with 480 will be below 10, means beats will be favored. Favored means becomes less than the second one. Okay, the correct option is 470 is correct. Okay, so next question number 138. Which of the following function represents the wave? Here, which of the following function represents the wave? So is LAN will not go for equation of wave, and exponential also will not go for LAN will not go for equation of wave, exponential also not go for equation of wave, and 1 by x is not also equation of wave. But if you take any x square term involving any term involving x square will have wave function. So x square means this has term having x square function. So correct option is x minus vt whole square is the correct wave representation. LAN not wave representation, exponential is also not wave representation. It is 1 by x. 1 by x is not also wave representation, but it is in the form of x square. X square means this x minus vt whole square will give x square term. So 138 option A is correct. Okay, so next question 139. The two sound waves are represented by y equal to a sin omega t minus kx, this omega t minus kx, and y equal to a cos omega t minus kx. The phase difference between the waves in water. Say if one function is sine, other function is cos. If one function is sine and the other function is cos, then the phase difference between them is definitely pi by 2. This is pi, not box pi. This is also pi. This is also pi. So which is the correct option? Pi by 2. If one function is sine, other function is cos, definitely the phase difference between the two waves is pi by 2, 90 degree. So no need to go for calculation. If one is sine function and other is cos function, between sine and cos 190 degree is the phase difference. So pi by 2 is what? The correct option. Okay, next question. Question number 140. I will go for question number 140. A string of linear density. There is a string of linear density. How much? 0.2 kg per meter is stretched with a force of 500 Newton. What is the tension? 500 Newton. Force or tension, both are same. It is T. Force or tension, both are same. It is T. 500 Newton. Linear density mu is 0.2 per kg per meter. A transverse wave of length 4 meter transverse wave of length 4 meter and amplitude is 1 by 1 meter is traveling along the string. The speed of the wave in meter per second. So what is the formula for speed of a wave? V equal to simple. V equal to root of t by mu. Do the calculation. Root of t. T is how much? 500 divided by mu. Mu is what? 0.2 kg per meter. So do the calculation. It will be what? 500 means 5000. 5000 by 2. 5000 means 5000 half is 2500. 2500 means it is 50. 50 meter per second is the correct option. So speed of wave is what? 50 meter per second. So option A is correct. So next question 141. Two wires made up of same material. There are two wires. They are made up of same material, are of equal lengths. They are of equal lengths, but the radii are in the ratio 1:2. Ratio is 1:2. On stretching each of these two strings by the same tension is also same. The ratio of fundamental frequency. See how you are going to solve this question. Okay, we know that they are same material means rho 1 is equal to rho 2. They are of same length means L1 equal to L2. They are such and the same tension means T1 equal to T2. Now here I am going to write the frequency. Frequency formula is F equal to 1 by 2L into root of T by mu. Root of T by mu. Now here I am going to calculate here mu. Mu can be written as, how to write mu? Mu can be written as mass per unit length m by L. Mass is density into volume divided by L. So density into volume is area into length. So LL cancels. So density into area. Density rho into what? Pi r square. So here rho is same. So mu can be directly proportional to what? R square. So the frequency will be, so rho is constant, deleted, pi is constant, deleted. So what happens here? Mu proportional to R square for rho constant. Okay, this only happens when rho is constant. So L is constant, length is same, tension is same. So it will be F proportional to 1 by root mu. F proportional to 1 by root mu. Root mu means what? Root of R square, because mu proportional to R square. So it is 1 by R. So if frequency is inversely proportional to radius, so F1 by F2, the ratio of fundamental frequency is equal to R2 by reciprocal, inversely proportional, R2 by R1. But R1 by R2 is 1:2. It is R1 by R2 it is. Now R2 by R1 will be 2:1. So 2:1 is the correct option. So option B is correct. Okay, with this let me stop now. Thank you.